Hello, and welcome to 11785 Introduction to Deep Networks. This is the fall 2018 edition of the course, and in this lecture we're going to focus on the logistics of the course. But first, here's a fact that we're all familiar with. Neural networks have taken over most AI tasks in today's world. They've become one of the major thrust areas in many pattern recognition and prediction and analysis problems. In many problems, they've actually established the state of the art, often exceeding previous benchmarks by very large margins. Here are some examples. Automatic speech recognition. For decades, we have been trying to develop automatic speech recognition systems that can perform as well as human beings and have failed miserably till very recently. Here's a headline from just a few years ago. Microsoft AI beats humans at speech recognition. And for the first time, on a standard benchmark task, they were able to outperform human beings using deep neural networks. Now, of course, most companies have automatic speech recognition systems that can outperform humans on several tasks. Here's another one, machine translation. If you had used Google Translate prior to November 2015, and if you had translated English to, say, Spanish, taken the translated Spanish and translated it back to English, what went in and what came out would not have looked similar at all. And then suddenly, in November 2015, Google Translate became a useful tool. And the translations actually began looking like something a human being might produce. And that's because they switched to using neural network-based translation. Here's yet another example. This is a picture I got from the web. I can't be sure of the authenticity of the picture, but here is a typical kind of result that you can now get for an image segmentation task using deep neural networks. In this picture, the system, the AI, has actually managed to segment out various objects and even label them. For example, it calls this a bicycle. It calls this a pushcart. This sort of performance was unimaginable just a few years ago, but now deep neural networks make this possible. Here's another example. This is from a website called sitehound.com. And they have a video purporting to show a deep neural network-based system tracking and labeling cars on the highway in real time. And here is a typical snapshot of the output. It's found and labeled a Nissan Sentra, a Honda Accord, a Honda CR-V. Now again, this is a phenomenal performance, and this wouldn't be possible without deep neural networks. Games. One of the standard tests for AI for very many years was whether a computer could beat human beings in games that were fundamentally intellectual in nature, like chess. We, of course, managed to build computer algorithms that could beat humans at chess a couple of decades ago, but Go was said to be the benchmark. It was assumed that a computer could never beat humans at Go. And then just a couple of years earlier, we had the first AlphaGo system, which beat the world champion Lee Sedol. And these days, you can actually download a program from the web where the game learns to play Go from scratch, and in a few short hours can beat a world champion. And that has been powered using deep neural networks. Here's an example of assigning captions to images. These are various, I don't believe you can actually read the captions, but if you look at the PPT, you should be able to. And what you will find is that the computer has correctly captioned each of these images with amazing accuracy. And consider this, trying to describe an image such as this is actually a very complicated task even for a human being, but the computer is able to do this, and that is being done by a deep neural network. And so on, in a variety of problems, from art to astronomy to healthcare and even predicting stock markets, deep neural networks are setting the state of the art and producing amazing results, and these things are only getting better with time. And of course, there's the business with the employment market. With all of the success of deep neural networks, these days, if you're not familiar with deep neural networks and you are not an expert in the technology in some sense, it actually becomes hard to get a job in the tech world. And so the objectives of this course are to try to impart some knowledge about this amazing new phenomenon to you guys. We want you to understand neural networks. We want you to be able to comprehend the models that do all of the previously mentioned tasks and maybe even build these models. We want you to be familiar with terminology. For example, here is a very nice blog, www.datasciencecentral.com/profile/blogs/concise visual summary of deep learning architectures. This blog actually maintains a list of all of the latest neural network architectures that are being employed, and it's our hope that when you're done with this course, you will be able to comprehend all of these architectures. Our objective also is to finally enable you to be able to fearlessly design, build, and train networks for a variety of tasks. We're not claiming that you're going to become an expert in deep neural networks in this one course, but although you may not be an expert, you'll actually be fairly handy, and it will set you up for further work. At a broad level, here is what we will be trying to teach you. We will cover concepts, starting with some historical perspective, talk about different types of neural networks and underlying ideas, how neural networks can be learned, including training and practical issues, and about various kinds of architectures and applications. The course is going to try to balance implementation and theory, with the focus being on trying to impart concepts to you. We are not so highly focused on the theoretical aspects, the mathematics, the squiggles. We want you to understand the subject. And there's also a heavy focus on practical implementation. We hope that when you're done with the course, you'll be familiar with training. You will be able to implement various neural network architectures, implement state-of-art solutions for some problems, and overall, you must be set up for further research or work in your research area using deep neural networks. The topics we will cover are these. We're going to go through basic network formalisms, including multi-layer perceptrons, convolutional networks, recurrent networks, Boltzmann machines. We will look at some advanced formalisms like generative models such as variational autoencoders and adversarial models like GANs. We will touch upon several practical topics like computer vision, how you recognize images, text processing, modeling and generating language, machine translation, that is sequence-to-sequence modeling, modeling distributions and generating data, reinforcement learning in games, and speech recognition. There is a list of books on the course webpage, which is deeplearning.cs.cmu.edu. We will also be putting up additional reading material on the course pages. Although these books and this reading material broadly guide the course, we are not following any one book or any one source. The material that we will be presenting during the course itself has been drawn from many sources, some of which are listed here. I am the instructor for the course. I'm Bhiksha, and that there is my phone number should you want to contact me. We have 14 TAs for the course. The list of TAs with their email IDs is on the course page. We have TAs for the Pittsburgh campus, for Kigali, for the Silicon Valley campus, and for Doha. If you have any problems during the course, please approach your local TA first and then post on Piazza, and if both of those fail, then you may want to approach a TA from a different location. Office hours for the TAs will be put on the course web pages. The course web page itself is deeplearning.cs.cmu.edu. The lectures, we're going to have both in-class and online sections for the course. So I will be teaching in a classroom, but the lectures will be broadcast, they will be streamed. They will also be recorded and uploaded to YouTube. And students from the online section at Pittsburgh and from the sections in Kigali, Silicon Valley, and Doha can both follow the lectures, the streamed lectures, and watch them on video. It's important that all of you actually view the lectures, even if you know think you know the topic, because trust me, your ability to get good marks in the course is going to depend on actually having viewed the lectures. The lecture schedule is going to be put up on the website. We currently have a schedule on the website. It's tentative in the sense that as you go into the second half of the course, things get a little fuzzy, and some of the schedule may actually change from what is actually on the web page. Also, we have a number of guest lectures by Scott Falman, Graham Newbegg, Richard Stern, Joseph Keshet, and maybe one more guest lecture. And the schedule for the guest lectures is always a bit flexible, so this also contributes to the potential fuzziness of the schedule for the latter half of the course. But you can find a general guideline for what the course schedule is going to be like and the syllabus on the course page. We have recitations, 13 of them. The recitations will cover implementation details and basic exercises. And it's very important that you actually view or attend the recitations if you wish to get the maximum out of the course. The recitations are also going to be recorded, and the recitations will also be up on YouTube. The topic list for the recitations is also on the course schedule on the course page. And again, I must emphasize, I strongly recommend that you attend all recitations, even if you think you know everything. You will be surprised at what you learn. The grading for the course is as follows. We don't have a final exam or a midterm. You will have weekly quizzes. Every week there will be a quiz. It's a multiple choice quiz. And these quizzes are going to be worth 24% of your marks. We have 5 homeworks. The first one is a preparatory homework, which is worth 1% of your marks, that has already been released, and you have worked on it. The remaining 4, the first one is on basic multilayer perceptrons. There's a homework on convolutional neural networks, 1 on recurrent networks, and 1 on sequence-to-sequence modeling. Everybody is expected to work on a project. The project will be worth 35% of your grade if you're in 11785. If you're in 11485, you will not need to do the project. Your grade is going to be dependent entirely on your quizzes and your homeworks. For those who are working on the project, you will have to submit a project proposal, which is worth 5% of your grade, a midterm report, which is also worth 5% of your grade and is important, because not submitting a midterm report means the rest of this will not apply to you. 15% of the grade for the project is dependent on a final project presentation, and the final 10% is going to be dependent on the project report that you will submit. The quizzes, each week you will have a quiz, 14 in all. The quizzes are 10 multiple choice questions which relate to the topics covered that week. Every week quizzes will be released. The quiz will be released on Friday and it will be closed on Saturday night. Information about the quiz will be posted on Piazza. The actual schedule for releasing and closing the quiz may sometimes change, but generally it will be released on Friday and closed on Saturday. Of the 14 quizzes that we will give you, we will consider the best 12 that you have scored. And this is expected to account for any circumstances which prevent you from maybe answering a quiz or 2, or maybe you just perform poorly on a couple by chance. So the best 12 of 14 is expected to help you cover up for any incidental loss of performance in the quizzes. The course slides will be up on the web page, and the slides often contain a lot more information than is presented in class. Very often when I present the lecture in class, I'll be skipping over slides, but those slides will be part of the slide deck that's put up on the page. And the quizzes will contain questions from the topics that are on the slides but are not presented in class. And they will also include topics covered in class but that are not on the online slides, which means that if you want to score well in the quizzes, it's important for you not only to see the slides but also to view the lecture. The homeworks, of which you're going to have 4 more, come in 2 flavors. Every homework will have a part which is auto-graded and has deterministic solutions. You will have to upload your solutions to AutoLab, and we'll compare your solutions to what we know the solutions must be to grade you. The second part of the homework will be Kaggle problems, where you will compete with your classmates on a Kaggle leaderboard. Now, these will be on various tasks, and for each of these tasks, we will post performance cutoffs for the various grades A, B, and C. And those grades map onto these marks. If you get an A, you'll get 100 points for the class, for the homework. B gives you an 80, C gives you a 60, D gives you a 40. If you don't submit the homework, you don't get any marks. But if you perform extraordinarily well, you will get an A+, which will give you 105 points. We will not be posting a cutoff for A+. That depends on how everybody has performed. And the actual scores we will give you are not going to be quantized. They will be linearly interpolated between the grade cutoffs. Now, well, not really linearly interpolated. The interpolation curves will actually depend on the distribution of curves of scores, so it's important that you try to perform as well as you possibly can. The homeworks have multiple deadlines. Since every homework has both an auto-graded component and a Kaggle component, there will be separate deadlines for the auto-graded component and the Kaggle. And the Kaggle component in turn will have multiple deadlines. We want to encourage you to submit. Now, what has happened in the past is that people would put off working on their homeworks till the very last minute and begin submitting in a panic-stricken manner at the last minute and not get things done. And then, of course, we have to deal with all of the questions and problems that arise. So there will be an initial submission deadline. Now, this is Kaggle. You can keep submitting your solutions repeatedly. We expect your first submission to happen before the initial submission deadline. So this way we know that you actually begun working on it. If you don't make the initial submission deadline, then all subsequent scores for that homework are going to be scaled down by 0.8 or by multiplication by 0.8. There's also a full submission deadline, which is when you will make your final submission, and your final submission must occur before this deadline to be eligible for full marks. But then you could actually submit late even after this full submission deadline, and if you submit late, then you will get reduced marks. But then this means that if you haven't actually managed to get your homework done properly before the full submission deadline, you can continue to update your homework for a while and still get maybe 80% of the marks that you would have got if you had met the full deadline. So even this extended deadline is going to stop at some point. At some point for each homework, we will release the solutions, whereupon we will stop accepting further submissions. Now, the late policy, everybody is going to get up to 5 total slack days, which doesn't apply to the initial submission deadline. Everybody must make the initial submission deadline if you want full marks. You can distribute these 5 slack days across your homework as you want. So you have a total of 5. You could apply maybe 1 to the first homework, 3 to the second, and 1 to the third, or 2 to the first, 3 to the second, and none to the third. It's up to you. But the moment you begin using your slack days, you become ineligible for an A+, and the maximum you can get is an A. Also, once you go past the full submission deadline, although you can continue to submit on Kaggle, your name will not show up on the leaderboard. Although Kaggle will continue to accept your submission and we will know how you have performed. But regardless of how well you performed, it won't show up on the leaderboard. This is to be fair to the students who have actually made the final submission deadline. So here is a little chart of how the homework deadlines work. If you make the initial submission deadline, then if you submit before the full submission deadline, you can get a maximum of 105 marks. But then if you begin using your slack days, then the maximum you can get during the slack period is 100 marks. If you go beyond your slack deadline, then further delays will lose you marks at 10% per day for 2 days. And then if you're more than 2 days beyond your slack days, the maximum you can get is 80 marks. And that will continue till the drop dead deadline, after which you will get no marks for the homework. Now, if you didn't make the initial submission deadline, all of these marks are going to get multiplied by 0.8. So the red line shows what you would get for your submissions. If you didn't make your initial submission deadline but still did manage to submit the final homework before the full submission deadline, then the maximum you can get is 0.8 times 105. If you go into slack, you're going to get a 0.8. That's your maximum. If you go beyond the slack dates, then the best you can hope to get is 64% of your marks. And of course, you cannot submit anything after the drop dead deadline. The course is implementation heavy. It will require a lot of coding and a lot of experimenting. We're going to work on some large data sets. The language of choice is Python. The toolkit of choice is PyTorch. And all of our TAs are comfortable with PyTorch and can help you. You're welcome to use other languages and toolkits, but for these, the TAs will not be able to help with coding or homework because not everybody has worked on all of these toolkits. The only one for which we can actually assure you help is PyTorch. We do have some support for TensorFlow, but that's going to be significantly more limited than what you would get for PyTorch. Also at this point, I hope you have already gone through Recitation 0 and that you have worked on Homework 0. Homework 0 carries marks. All discussions will be on Piazza. We are going to, of course, this is an implementation heavy course, so you're going to have to implement stuff, which means you will need compute infrastructure. All students will get Amazon tokens. Initially, you'll get a token for $50, and later on, you can get additional tokens of $50 for up to a total of $150 for AWS services. You can use this for your homeworks. Now, just to warn you, this course is a lot of work. It's not easy. In case you haven't gotten it yet, it's a lot of work. And if you don't believe me, it's a lot of work. And if you still don't believe me, it's a lot of work. It's not meant for chicken. If you think you're just going to start the course and at some point it's going to get easier, it's not. And if you think you're going to take it easy, then this is not the course for you. If it doesn't make a whole lot of sense for you to spend a lot of effort, complete half the course, and then drop out, because that effort will be wasted. So I'm warning you up front that you can expect to have to work very hard on the course, but it will be worth it. We are not interested in deadlines, and we are not interested in enforcing work on you. That is not the point. The objective of the course is to teach you. And so our evaluation, to the extent possible, is going to be based on mastery rather than on presence or going through the motions. Our quizzes will test your understanding of topics covered in the lectures. The homeworks are meant to teach you to implement complex networks, which means that because this is mastery-based evaluation, we have a very lax deadline structure, as you saw for the homeworks, because our primary focus is to try to get you to go through the work and actually learn the subject. Our target is that anyone who gets an A in the course is going to be technically ready for a job in deep learning. Again, this doesn't mean that you're going to be the world's greatest expert, but you're definitely going to be fit to do a job in deep learning. And to our credit, I believe many of the students who took this course last semester actually benefited greatly from it in their search for internships and jobs. Again, please do go through the videos for Recitation 0 and also complete Homework 0. These are essential for you to gain comfort with the coding required in the following homeworks. Homework 1, Part 1 also has many components intended to help you later in the course. So if Homework 1, Part 1, which is going to be released shortly after the semester begins, seems a bit dense, please bear with it, because this is actually going to make subsequent homeworks easier for you to do. And remember, things get tougher. So Homework 1 is in fact the easiest homework you're going to have. And thank you for watching. If you have any questions, please post them on Piazza.